So I will take the same example as given in lead code, and let's start solving this approach, the top-down approach that we discussed. So I've got this nums array of having this 5 ones, and we have to get the target of 3 for all the expressions possible. So let me first of all place just use this array index here and nums I. So this is, I just put it as indices here. So now we have given the statement that each of these numbers, each of these elements here, that can be either +1 or plus or minus, right? And then we have to find the expressions. So let's start with the very first index here. So what I will do is that I will maintain two variables together. So I will maintain one as index, okay, and the other I would as a total. By total, I mean that once I reach at, say, first index or second index, and I will just maintain that what are the total number of, what is the final expression or evaluation at that point of time, or at that particular index. For example, if I have reached as index, say 2 here, at this point, I will see that the total will contain that how many total expressions have been formed so far. For example, if I chose 1, +1, and then -1, so it would be 2 minus 1 is equal to 2 minus 1 would be 1. So this total will indicate that value. Similarly, it can have multiple values like this, that if I chose, say, -1, -1, -1, so it would be -3. So this total will be actually is more like an accumulator, that at this particular index, how many, what is the target, what is the expression value that we have found so far. So let me start with the very base case. I mean, we start with 0, 0, total would be 0. And now we see that we move to this position, right? Now this 1 has indicated that it can be +1 or -1. Or in other words, I can write it as like this, right? So at the 0th index, we are right now at 0th index, and the element here is 1. So it can be, the total can be 0 plus 1, right? Total, because it's so far is 0. And if I treat this 1 as plus of 1, then this would be giving me at that 0, I have got 1. So let me also expand it a little bit. Yeah. So okay. So this is like one condition at this point. If I treat this one as plus 1, and the other condition would be that if I treat this one as -1. So in that case, for the 0th index, it would be 0. Total would be 0 minus 1, which is 0 minus 1. Okay. So these are the two totals. Like if I choose for 0th index, we have got a total of 1 and -1. Now again, from this point, we have got two. I can say treat this as a tree now, and then we'll further expand both of these decision trees, for example, and then we try to expand from this point. So let's go with this first again. So for 0 and 1, now we are at index 1 here. So I will mark the first as index 1. And now again, this one can be treated as +1 or -1. So now our total here is 1 already. So we'll just take the condition of plus first. So it would be 1 plus 1, right? And it will give me this one. So at index 1, one possibility is that we have the total of 2 at this point. And the other condition is that I use this 1 as -1. So in that case, it would be 1, and the total here was 1 minus 1. So it would be 1 of 0. So these are the two possible like the branches or like the decisions that we can take if we choose this 0 and 1. So we'll get in one option, we get the option of 2, as total, and then other one we get 0. So this is one for 0, 1. Similarly, for 0 and -1, we will again see that what are the two similar to this condition. We will see that we will choose one as +1 or -1 and see the values here. So I take this value as 1, and then the total before the total here is -1. So it would be, say for example, I take -1 plus 1 first. Okay, so it would be 1 and 0. And in the other condition, if I treat this 1 as -1, then in that case, at index 1, if we choose this, so -1 was the previous value, and then -1 again. So it would be 1 and -2, right? Okay. Now we see that these are the if I go through this branch, right? If I go from here, here, and here, here, and here, this is like one way of expression that we are going forward. So we take from +1 here, and we are getting the total as 1 and 2. Similarly, the other branch or other decision that has been following up here is that if I choose this and then I chose this, so this is one way that we are going forward. Similar goes for this. One way is this, and this, and the one way is this, and this, right? So these are the different paths that we are going. And we see that here, one thing is, at this point, we have got at index 1, if we go through this path, then we are having this 1 and 0, same as once we go from this path to this path to this path, right? 1 and 0 are still same. So here we see that the problems are overlapping. And as we have seen in all the previous 21 examples that we have solved so far, that whenever there's a problems overlapping, we have to be dividing this problem into sub-problems, right? And we are also seeing that we are having sub-problems which are overlapping. And this is one of the conditions that where we can apply dynamic programming solution, right? So again, because there could be like a lot of branches from here onwards, I will just take one example. Say I will just take this example and try to solve, and we'll see that whether we are able to reach to the target of 3. I mean, once the total here reaches as target given here as 3, and we have also exhausted all the indices. I mean, if we reach to fourth index, which is our last element, then this would be like one way where we have found like one way where we can find a target sum using this decision that we are creating. So let's go ahead with it. I will just take one example here. I cannot cover all of them, but it would be very similar.